This is lab 4, dealing with the physics of extreme sports with ropes. Just a brief introduction. The purpose of this lab, we will be analyzing a video of a spring's oscillation in the X and Y directions pulled by a weight attached at the base of the spring. A video of the spring was placed in tracker, and then this position time data will be analyzed. The data was then placed into GlowScript to run a simulation for the oscillation to determine period, spring constant, and initial length. This fundamental concept used in this lab, we have the energy principle, which states the change in energy of the system equals change in kinetic plus change in potential gravitational plus change in potential spring equals the work of the surroundings. And then below are listed the expressions for kinetic energy, spring potential energy, and gravitational potential energy, and relative to Earth's surface there. And then the other concept, which we've seen in just about every lab so far, is Newton's second law, which states that final velocity equals initial plus net force divided by mass times the change in time. To find the spring constant and spring length, we can find spring constant from the period given. The formula, period equals 2 pi times square root of m over spring constant. As we just rearrange and solve for a spring constant, we get that expression there, which will help us solve an expression for the spring constant given the data produced from tracker and GlowScript. With the spring constant, we can find the relaxed spring length, L naught, which is derived from there. You see L naught equals the compressed length minus mg over the spring constant. And then the initial conditions gathered from the pre-lab video to put into the GlowScript. We have a mass of 0.402 kilograms, a period of oscillation in the y direction of 1.52 seconds, the spring constant of 6.872 newtons per meter, an uncompressed length of 0.1267 meters, and a compressed length of 0.7 meters. Now I'll move into the tracker video. As you see here, I calibrated the length similar to what was in the pre-lecture video. And then I'll run it here. We see over 100 data points gathered to track the weight's motion on the spring. And we see a nice oscillation back and forth around its initial rest straight line. And as we see here, we can get an estimate for the period in the X by looking at this first graph right here. And we will copy these data points into Excel, which we move into our GlowScript code. As you see here, we change the mass to the initial conditions given, 0.402 kilograms. We change the position to the initial position found in the tracker video, and we can also find the initial velocity vector in the tracker video. We change the delta t to 1 over 210 just to get more data points than the tracker. And then here, we plug in the spring constant and the relaxed length of the spring, also from the video. We also plug in these equations for L, L hat, and S. We then have the various equations for kinetic energy, potential gravitational energy, potential spring energy, and energy, as we see here, to get the correct expressions for all these. And then moving into the loop itself, we have the expressions for force of gravity, the spring force, and the net force. And then we also put the same formulas from before just to update each concept there. And we run this program using our data. We choose the file that expresses this data from tracker. And we see motion similar to tracker there, that oscillation. As you see, there's the energy and time, X position versus time, and Y position versus time. Hide that. We do see there is some variance in X and Y position graphs, as you see here. This is due to user error plotting the center of mass on the tracker due to dissipative forces, surrounding forces, etc. But if adjusted, as you see here, if the experiment would start where it should have there, the period looks very similar in each, which is good. And also, we see here, energy is conserved. The delta E is 0 throughout. There's no outside forces acting on the system. And as you see here, the red represents potential energy gravitational and the green represents spring potential. And we see those are both exactly inverse. So we do see this conservation of energy present here. And just to close this, what is the difference between the y component and x component? as we see, the y was all given to us initially, so I just restated those. And the x, we can use those expressions. I'll go back from earlier, these formulas for period, spring constant, and uncompressed length to plug in the values we got from the tracker and the glow script here to get period of 1.683 seconds, spring constant of 5.603 newtons per meter, and uncompressed length of 0.0062 meters. And as we see, the periods are similar as we see x is greater than y.